Part 5 of graphing trig functions. Here we go. So these are handwritten because I messed something up a little bit, but that's okay. So number 15, y equals sine of 1/4 theta plus 2 pi. All right. Well, our phase shift, it's what's added to theta. So our phase shift is left 2 pi. Period. Period is what is multiplied by theta, or outside these parentheses, it's not the 1/4. I probably said that wrong, but it's 2 pi. The normal period of sine divided by 1/4. Dividing is the same as multiplying by the reciprocal, so the period is 8 pi. Amplitude is what's multiplied out here, which is in understood ones. The amplitude is 1. And there is nothing added outside here, so the vertical shift is 0. We will go ahead and draw our horizontal axis. We're not going to put the y-axis, although this one we probably could, but we'll not do that quite yet. We're going left 2 pi, so that's negative 2 pi. So negative 2 pi is our starting point. And we have to add 8 pi. So starting point of our first cycle is negative 2 pi. And then we're going to add the period, which in this case is 8 pi, to get the end point. And this one will work out a little bit easier. So we have negative 2 pi plus 8 pi is going to give us our ending point of 6 pi. So that's pretty spread out. So I'm going to put 6 pi way down here, 6 pi. We divide that into 4 equal parts. We can think through this different ways. We could think what's halfway between negative 2 and 6. So we could add negative 2 plus 6 is 4, divided by 2 is 2. So halfway between here is 2 pi. Also, we can think the whole period, I'm probably going to erase this. This whole period is 8 pi divided into 4 equal parts. So each part is 2 pi. And so add 2 pi, you get to 0. Add 2 pi, you get to 2 pi. Add 2 pi, you get to 4 pi. Add 2 pi, you're at 6 pi. So I'll write all those in now. So this is 0, 2 pi, 4 pi, and 6 pi. The amplitude is 1. We can draw our y-axis now. That is actually one of our specific points that we're going to be working with. So we can even mark our amplitude of 1 and negative 1. However, this is our starting spot. So we're graphing sine. The vertical shift is 0, so we're not going up or down at all. So this is sine. So sine starts at 0 at our starting point. At the first quarter part there, it goes up to 1, back down to 0, down to negative 1, back up to 0, and then that would continue. And here is a graph of y equals sine of 1/4 theta plus 2 pi. Very similarly, we have number 16. So our phase shift is plus 3 pi over 2. So we're going to go left 3 pi over 2, which obviously is negative 3 pi over 2 is going to be our starting point. Our period is, the normal cosine of period is 2 pi divided by this 1/3 here. because that's what's multiplied. Dividing by 1/3. Dividing is the same as multiplying by the reciprocal, so the period is 6 pi. The amplitude is simply 1. And the vertical shift, nothing's added out here, so it's 0. Horizontal axis. We're not going to draw in the y-axis yet since we have a phase shift. Let's talk about that phase shift. Our starting point is -3 pi over 2, and we are going to add the period, which is 6 pi, to get the end point of the first cycle. So we will put our starting point at -3 pi over 2. It's a pretty long period, so I'll go ahead and put a mark here. Except we have to find our endpoint, so this is -3 pi over 2 plus 6 pi. We can get a common denominator of 2, so we can actually add these. And so this is -3 pi over 2 plus 12 pi over 2, which will give us 9 pi over 2. So our endpoint is 9 pi over 2. You could have thought of these as mixed numbers as well, and that might have been helpful. We're going to divide that into 4 equal parts. Halfway between -3 and 9 is 3, so this is going to be 3 halves. And then halfway between 3 and 9 is 6, so this is going to be 6 halves, which is just 3 pi. And this actually is 0. So there's our y-axis. Sometimes it shows up as one of these important spots along here, and sometimes it doesn't. Amplitude is 1. So we're up at 1 and down at -1. This is our starting position, though. We are graphing cosine. So cosine starts at the higher point. Let's go ahead and put in this guideline. Both guidelines, actually. So we start up, go down to 0, down to -1, back up to 0, back up to 1. And put a couple more points in there to follow the pattern. And we have our graph. Oops, missed the point, just make the point bigger. Let's do one more. Let's do number 17. This is minus pi over 6. So we're going to be right to pi over 6. Here's a 4 here. That's has to do with our period. So period, zoom in a little bit here, is the normal period of sine, which is 2 pi divided by that 4. So the period is 1/2 pi, or pi over 2. The amplitude is an understood 1. There is nothing added outside here. So the vertical shift is 0. We can sketch in our horizontal axis. Our starting point of our first cycle is pi over 6, and we will add the period, which is 1/2 pi, to get our endpoint of the first cycle. So let's mark this as pi over 6. We're going to take pi over 6, our starting point, plus the period of pi over 2 to get our end point. Well, we need a common denominator, so we need a 3 over here, 3. So this ends up being pi over 6 plus 3 pi over 6 gives us 4 pi over 6 for our ending point, which is actually 2 pi over 3. So a half pi is a pretty small period, so let's just put that right here. Well, we're not putting half. To make that clear, we're putting our ending point here, which is 2 pi over 3. We're going to split this into 4 equal parts. I mentioned it before, and I'm going to do it this way again. If you get mixed up on finding the values for these spots when we split it into 4 equal parts, you can still graph it. I do want you to put those values, but don't get too hung up on those. So our amplitude is 1. This is not our y-axis, so I'm going to put a dotted line here, but this is our starting point. So our amplitude is 1, so we can go up to 1 and down to -1. This is a sine graph, so sine starts at 0, goes up to 1, down to 0, down to -1, back up to 0, and that pattern continues forever and ever. All right, so there's the graph. So we can still draw the graph. Let's go ahead and focus on these highlighted ones I'm putting here. I would probably think of it this way. We know that our period for one full cycle was 1/2 pi. But if we divide 1/2 into 4 equal parts, so we want to take 1/2 pi divided by 4, well, we know division is the same as multiplying by the reciprocal, so multiplied by 1/4. So each one of these is 1/8 pi. Oh boy, well, in order to add, we need a common denominator. So we have this pi over 6. We're biting off quite a bit here. So we have pi over 6 plus pi over 8. Common denominator is 24. So this needs a 4 over 4, and this needs a 3 over 3. So this is actually 4 pi over 24 plus 3 pi over 24 is 7 pi over 24. So this is 7 pi over 24. Ugh. Now we're going to take that 7 pi over 24 and we're going to add another 8th. I have to go all over the place here. So we're taking the 7 pi over 24, adding an 8th. So we need another common denominator, so we multiply this by 3 over 3. And this is going to be 7 pi over 24 plus 3 pi over 24. And that's 10 pi over 24. 10, so this is going to be 10 pi over 24, which does reduce, but let's just leave it like that for now. Then we're going to take that 10 pi over 24 and add another 1/8. Well, realize 1/8 pi with a denominator of 3, so multiplying by 3 over 3 is 3 pi over 24. And so that's going to give us 13 pi over 24. So that's going to be this spot, 13 pi over 24. And then just to check here, we're going to take that 13 pi over 24, add another 1/8 pi, so this one, but 3 pi over 24, which gives us 16 pi over 24, which should be this spot right here, which that's hard to see. That says 2 pi over 3, and this does reduce to 2 pi over 3. So finding those fractions in there did take a while, but we were able to graph this even before we found those fractions.